and welcome to this online revision session for AQA FP1, in which we're going to do the June 2010 question 5, which covers the topic of differentiation from first principles. In other words, finding the gradient of a curve at a point. So you can see in this question we're given the curve y equals x cubed minus 12x. We're given the point 2 minus 16, which is somewhere on that curve, and then we're told a second point B is on the curve where its x component is 2 plus h. Hopefully you remember something about differentiation from first principles, that this second point is then a distance h from the first point. You've got 2 and 2 plus h. So in part A they're asking us to show that the gradient of the line between points A and B is 6h plus h squared. So there's two parts or processes that we need to go through. Firstly, for the coordinate B, we need to know its y coordinate. So to obtain the y coordinate of B, we need to substitute its x value into the equation that we're given to find the y value. So the y value will be equal to 2 plus h cubed, because that's the x value, cubed, minus 12 lots of that x value. Having done that, we need to simplify it. So if we take 2 plus h and work out its cube, and we know that 2 cubed is 8, and then we're going to get the 2 times the h times another 2, so that will give us 4h, and we know that that will occur 3 times using Pascal's triangle, so that will end up being plus 12h, and then we get an h times a 2, which gives us 2h squared, and again from Pascal's triangle that occurs 3 times, so we will get 6h squared, and then finally we get the h multiplied by the h multiplied by the h, which will give us h cubed. We then multiply out the second bracket, we're going to get minus 24, and the 2 times the 12, and minus 12h. And so we collect together what terms we've got. We've got 8 minus 24, so that's minus 16. Then we've got a 12h and a minus 12h, they both disappear. So we just get plus 6h squared plus an h cubed. So that is the y component at B. Okay. So to get the gradient of this line, you have to remember the gradient is up over across, so it's the difference in y over the difference in x. So to get the difference in y, we've got to take the minus 16 plus 6h squared plus h cubed and subtract the y at the point A, which of course is negative 16. I have no idea to just put brackets around all of that and that, just to show we've done the difference in y, and that is all divided then by the difference in x. Well, 2 plus h is the value at B, 2 is the value at A, so the difference in the x values is just h. Now we can see we've got a minus 16, so that's plus 16, and this is a minus 16, so these two will cancel each other out. So we're just left with 6h squared plus h cubed over h. So if we divide through by h, that will give me 6h plus h squared as my gradient. So where are we picking up the marks in this first part? Well, for a method mark, you'll get a method mark for stating how you're going to find the value of y at the point B, and making some sort of attempt at simplifying that and obtaining this statement here will give you 1 mark. Then writing down an appropriate method here for the gradient will give you a method mark, and then obtaining the 6h plus h squared will give you an accuracy mark at that point there. On to part B. You've now got to explain how the result of part A can be used to show that A is a stationary point on the curve. Well, to know what the gradient actually is at A, we have to let h get smaller and smaller, so B moves closer and closer to A. So to do that, you have to let h tends to 0. So as h tends to 0, 6h plus h squared will also tend to 0, which is implying that the gradient at A is equal to 0, which of course is implying that it's stationary, because you remember a stationary point is one where the gradient of the curve at that point is 0. Explaining that clearly will give you 2 marks. If all you do is write down h equals 0, you'll only get 1 mark. You've got to show that the limit as h tends to 0 is 0, i.e. that the gradient, the 6h plus h squared, is tending to 0 as h tends to 0. Hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.